Alright, let's take a look at functions and their inverses, also commonly known as FI 1.1. Alright, so looking at this first part, it says inverse operations undo each other. For instance, addition and subtraction are inverse operations, so are multiplication and division. In mathematics, it is often convenient to undo several operations in order to solve for a variable. Okay, some simple stuff. So, how would we undo multiplication by 3? By dividing by 3, right? Solving an equation like that. Okay, so 2, 3, you guys should be able to get. You should be able to get 4 as well. Now let's look at number 5. Okay, we would first undo the cube root by, just like square, hint hint, and square root are opposites, cube and cube root are opposites. So first we would cube both sides. Okay, those cube and cube root would undo, so we'd have x plus 1 equals 2 cubed is 8, because that's 2 times 2 times 2. Okay, then we would minus by 1 to get that x by itself. Okay, so use that same concept with number 6. This time you have a fourth, to the fourth power, so powers and roots are opposite each other. Okay, number 7, we'll take a look at that one. So we've got x minus 9 squared equals 49. So, to get rid of that square, we take the square root. So we would square root everything. That gives us x minus 9 equals, square root of 47 is positive or negative 7, but we'll just deal with the positives for this case. Then what would be the next step? Would be adding 9 to get it by itself. Okay, so finish the rest of those, and it's a similar idea to that. Now, I'm going to skip ahead for a second and look at these last ones. So these last ones were basically just dealing with function notation. We've got 3 functions, right? Remember, f of x is a name, g of x is a name, h of x is a name. It's saying they're different ones, they're equations with the variables x. Okay? That is all they are saying. So when we see something like this, it's saying, okay, take our function, but instead of x, let's put a 10 in there. So if we're putting a 10 in for x, everywhere there's an x, we put a 10. So f of 10 equals 10. When we put 10 into this function of f, we get 10 back. Okay, 16. f of x equals x. Okay, put in an a instead, and you just change x to a. Okay, same with 17. Now look at 19. G of x of negative 2. So we take a look at this function, g of x now. So where g of x is equal to 5x minus 12, instead of x, we replace that x with a negative 2. And I just got distracted by someone knocking at my door. But we're plugging negative 2 in for x. So everywhere there's an x, put a negative 2. Now, on this side, you don't have to do anything to it. That's just telling you, this is my output when my input is negative 2. So then we solve the right side. 5 times negative 2 is negative 10. Negative 10 minus 12 is negative 22. Okay, look at 21. This one's a little trickier. So we have g of x, but instead of g of x, I'm going to put g of a plus b. So everywhere there's an x, I'm going to put an a plus b, minus 12. Okay, now we're done with that. We can't add a and b, so I'm just going to distribute the 5 to get 5a plus 5b minus 12. And honestly, I can't do anything else besides that. Okay, now let's take a look at these ones. So h of x equals x squared plus 4x minus 7. So now it's getting more difficult. So h of 10. So everywhere there's an x, here, here, and here, I now replace with a 10. And I keep everything else the exact same. So now I solve. 10 squared is 100, plus 4 times 10 is 40, minus 7. 140 is 140. 100 plus 40 is 140. Minus 7, 133. That is the output, this meaning output, that is my result when we have an input of 10. You know, if I were making a table of values, I'd have h and x and h of x, and it would be 10 and 133. And I could do it for negative 2 and have negative 2 and some other number. Alright, now the last one would be 25, and this one's going to be a doozy probably. So h of a plus b equals a plus b squared plus 4 times a plus b minus 7. So a plus b squared, remember, this is basically FOIL. Okay, a times a is a squared, a times b is ab, a times b is ba, which that's the same thing. I could just rewrite that ab again, plus b squared. Okay, so I'm going to simplify that. So we get a squared plus 2ab plus b squared, plus, now we distribute the 4, so we get 4a plus 4b minus 7. Now, none of these can be joined together, so that is our answer. Kind of a big guy, but that's what it is. Okay, now if we look back at these ones, I may not do all of these, I may want you guys to kind of think about them. Number 8, an ordered pair. Okay, I'm not going to worry about reading about that, I'll let you guys do that. An ordered pair would be those two numbers, or these two numbers, or these two numbers. Basically any group of numbers that are cats and dogs together. So you need to write 5 of them. Okay, an explicit equation, that's like y equals 5x plus 3. Okay, if you remember from 2 years ago, recursive, if you learned it, that would be like the f of x equals f of n minus 1, or we used n's normally, f of n minus 1 plus 3. That's recursive. So they want the one you're more familiar with. Okay, except they want you to use D for dogs, C for cats. So using this information, they want you to try to find out what it would be. Okay, it shows how many dogs they can accommodate based on how many cats they have. So, you know, you've got to find that connection between what's happening. Okay, and basically the way to look at it is kind of look at slope. Okay, if we think of it like this, cats would kind of be like the x, dogs would be kind of like the y. So remember, slope is rise over run. So for every 4 cats, we're adding 4 cats each time, we are subtracting 1 dog. Okay, so we kind of think of it like this. You'd say my function f of c is equal to, okay, how many dogs do we start out with? We start out with 15 dogs. Okay, what are we doing to those 15 dogs? Well, for every 4 cats we have, we're going to subtract 1 dog. So it should look something like that. No, that's not looking right to me. Duh, I figured out what I did wrong. If dogs is like my y value, it's right, rise over 1, it'd be negative 1/4, not negative 4 over 1. That's where I made a mistake. So for every dog, because if we're thinking the coordinate plane, this is dogs, this is cats. Okay, dogs goes up on top. So it'd be negative 1/4 cats plus 15. There we go, that looks better. Okay, that would be an explicit. Okay, try number 10. Use the information in the table to write 5 ordered pairs that have dogs as the input value and cats as the output value. Okay, so think about that. Up here, this one, cats was the input, dogs were the output, so you're kind of flipping it around. So you're basically just taking your table and flip-flopping it. Okay, write an explicit equation that shows how many cats they can accommodate based on how many dogs they have. This is where we started out with. Okay, but what you've got to remember is, if you flip-flop it, this is where you start out with dogs. Okay, you're flip-flopping the whole thing. So you'd say g of dogs equals, we start out with 60 cats, then, our slope would be, if we're going backwards, our slope would be, let's see, it's kind of hard for me without switching it around. For every dog that goes up, we minus the cats. So it would be cats over dogs, so it would be negative 4d plus 60. It would look like that. Okay. Number 12, look at 8 and 10, try to figure that out, and try to answer number 13. Okay, we'll try to talk about it in class. I'm sure you guys will have lots of questions. I'm sorry it took me so long to get this up here, but here you go.